All right, this is a quick review for the quadrilateral exam, and I realized that the chaos caused by quadrilateral classification can quickly create confusion. And for that reason, I put together this quick little video that hopefully will help you better understand. Let's start with quadrilaterals. They're just simply polygons made up of 4 segments. So I'm using these sticks to make a quadrilateral. All we can really say about all quadrilaterals is that their interior angles sum to 360. How do we know? Well, if we take one of the diagonals of the quadrilateral, we see that it divides it into 2 triangles. Think about each triangle as having 180 degrees of interior angles. So you add 180 plus 180 and you get 360. But you're going to want to memorize that 360 degrees, those interior angles. One of the major category of quadrilaterals that we learned about were parallelograms. And of course, the name comes from the parallel sides. So with a little bit of artistic license, if we consider these 2 sticks to be parallel and we put 2 other parallel lines, so opposite parallel sides, then the shape here we would call a parallelogram. Okay, now parallelograms don't all look the same, right? Some parallelograms have 90-degree angles and we call those rectangles, right? So a rectangle is a parallelogram. Some parallelograms have congruent sides. All 4 sides are congruent. We call that equilateral, and we call this a rhombus, but it's still a parallelogram. And some rhombuses are rectangles. So if a rhombus is a rectangle, if it's equilateral and equiangular, made up of 90-degree angles, then it is a square. And a square is the royalty of parallelograms, as it carries all of the properties of all the other parallelograms. Okay, so the first property that we learned was that the opposite sides are congruent, right? So that means, in this case, the left side, the right side, the top side, the bottom side. All right. Secondly, we learned that the opposite angles are congruent, right? So this angle is congruent to this angle, and this angle is congruent to that angle. And we proved it by using corresponding angles and interior angles. But you don't have to worry about that, just memorize it. Also, consecutive angles are supplementary. You can remember that because consecutive angles just make up a same side interior angles, right? Parallel lines, a transversal, same side interior angles. So the fourth property, although it's my favorite property, it's just like a knife fight where both diagonals cut each other in half, right? So this part is equal to that part, and this part is equal to that part. So diagonals bisect each other. So these 4 properties of parallelograms are true of all parallelograms. They're true of rectangles, rhombuses, and squares. So what makes a parallelogram a rectangle? Rectangle literally means right angles. It's an equiangular quadrilateral. All 4 angles are congruent, and in fact, they are 90 degrees each, okay? This is still a parallelogram, meaning that all the properties of parallelograms apply. Opposite sides are congruent, opposite angles are congruent, etc. The diagonals bisect each other. But rectangles have one special property that is only true for parallelograms if it's a rectangle, and that is that the diagonals are congruent, right? The diagonals are congruent, they're the same length. And that means that if they bisect each other, they cut each other into 4 congruent pieces. And remember, a square is also a rectangle. So square is equilateral, rectangle, right? So squares also have diagonals that bisect each other. Okay, but the main property to remember for rectangles is that the diagonals are congruent. Okay, let's look at another special parallelogram. What makes the rhombus special is that it is equilateral. All 4 sides are congruent. Okay, and so the rhombus has all the properties of a parallelogram. Opposite sides are congruent, opposite angles are congruent, etc. But the rhombus also has 2 additional properties. One is that the diagonals, this one is pretty cool, the diagonals are perpendicular, right? In other words, they cross each other at a 90-degree angle. The second special property of rhombuses is that the diagonals bisect the angles. So this angle here is congruent to that angle there, right? This diagonal cuts that angle in half, it cuts this angle in half. We call that bisecting. So the diagonal bisects those angles. Of course, this diagonal bisects these angles. In addition to all the other properties of a parallelogram, the diagonals are perpendicular, and the diagonals bisect opposite angles. Square. So a square is a parallelogram, And it's also a rhombus because it's equilateral. And it's also a rectangle because it has right angles. And so it's equiangular. So an equilateral, equiangular quadrilateral is called a square. In fact, we can just use the word regular. Regular means it's equiangular and equilateral. So a square is a regular quadrilateral. That means the square is a rhombus, so it has the properties of a rhombus. The diagonals are perpendicular, and the diagonals bisect the opposite angles. A square is a rectangle, so it has the properties of a rectangle. The diagonals are congruent. And of course, a square is a parallelogram, so it has those four properties as well. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and of course, my favorite, the diagonals still bisect each other. Okay, so that is parallelograms in a nutshell. Let's look at a couple of quadrilaterals that are not parallelograms. So sometimes we can make a quadrilateral with exactly one pair of parallel sides, right? If I have only one pair of parallel sides, then we call that a trapezoid. Okay, so that's what makes a trapezoid unique. It has just exactly one pair of parallel sides. Now, the only property we really talked about with trapezoids, of course, it has the properties of a quadrilateral that the four angles sum to 360 degrees, but also because we have a parallel side, notice we have same side interior angles. So these two consecutive angles are supplementary. They add up to 180, and these two angles add up to 180 degrees. And that's most of what you need to know about a trapezoid. But there's a special trapezoid called an isosceles trapezoid. An isosceles trapezoid has a few special properties. So a trapezoid is isosceles if the two legs, right, we call these the legs, we call the parallel lines the bases. A trapezoid is isosceles if the legs are congruent. And this is a more familiar looking shape to us of a trapezoid. And the isosceles trapezoid, which if you think about an isosceles triangle, right, there's an isosceles triangle. If you just cut the head off of an isosceles triangle, you end up with an isosceles trapezoid. And an isosceles trapezoid, the base angles are congruent. And these are base angles up here as well. So these two are congruent and these two are congruent. So you get a BOGO. If you know one base angle, you know the other base angle on an isosceles trapezoid. Okay, but there's one other property that's important to know, and that's in an isosceles trapezoid. The diagonals are also congruent. I'm going to give you an answer to one of the questions on the test. So an isosceles trapezoid has the special feature that the diagonals are congruent. Okay, and you should remember that there is also a parallelogram where the diagonals are congruent, and that is the rectangle. So if I ask you on the test which quadrilaterals have diagonals that are congruent, the answers would be an isosceles trapezoid, also a rectangle. And I'm going to throw you one more, also a square, because remember, a square is just a rectangle. So these three would need to be selected. The last quadrilateral that we learned about is a kite, and a kite has no parallel lines whatsoever, right? No parallel lines. It's the only one, the only special quadrilateral that we learned about that has no parallel lines. So you might want to remember that. What's special about the kite is that it's made up of two congruent sides and another two congruent sides, right? But these can't all be the same length. So we have two of one length and two of a second length, okay? And it looks kind of like the kite you traditionally fly outside. If I take this diagonal across here, you can see that this would be an isosceles triangle, and this would be a different isosceles triangle. So if I put the other diagonal there, the first property of a kite is that the diagonals are perpendicular. Okay, so you may remember that rhombuses also have diagonals which are perpendicular. So sometimes students will confuse a rhombus and a kite. Remember that the kite, that these two sides are a different length than these two sides. In a rhombus, all four sides are the same length. But for both a kite and a rhombus, the diagonals are perpendicular. Okay, so they do have that in common. And also think about these diagonals as dividing the kite into four right triangles. And this allows us to use Pythagorean theorem to find those individual pieces and parts. So this diagonal running across here makes the diagonal so that if I reflect one side onto the other, we can see that they are congruent. All right, so I call this my diagonal of symmetry. And having a diagonal of symmetry tells me that everything on one side is congruent to the other side, right? So this side is congruent to this side is congruent to that side, this angle is congruent to that angle, this small angle here is congruent to this small angle here, and this small angle here is congruent to this small angle here. We can also say that this diagonal bisects these opposite angles. All right, so let's wrap things up with a Venn diagram. When we're talking about classifying quadrilaterals, that includes any shape, any figure that has four sides and four interior angles. Those four interior angles always sum to 360 degrees. The biggest group that we studied were parallelograms. and they include rectangles, which are equiangular. They include rhombuses, which are equilateral, and they include squares, which are both rectangles and rhombuses. Okay, the other two quadrilaterals we learned about were trapezoids, which have one pair of parallel sides and only one, exactly one. And then we talked about the special situation of kites, which have consecutive, congruent sides, but the opposite sides are not congruent. All right, I hope that was helpful. All right, study together, test alone.
Chaos caused by quadrilateral classification can quickly create confusion.
Chaos caused by quadrilateral classification can quickly create confusion.